Hi, this is section 4.2, and we're on page 215. This lesson is on graphing linear equations. Want to get some vocabulary out of the way first. I am on page 215. At the very top, you'll see in bold print, first or second sentence of the reading here, what is a solution of an equation in two variables? We'll be asked in our homework that we'll be asked if a ordered pair is a solution of an equation. Okay, what are they asking us there? A solution of an equation in two variables is an ordered pair. Now remember, ordered pair is, some XY pairing, which makes the open sentence true. So just to make sure I'm clear on what that is, remember an open sentence earlier in the year was an equation that had a variable in it. Well, equations can even have more than a variable. It could have two variables. So here's an open sentence in two variables, like 2x plus y equals 8. 3, 2 would be a solution to this open sentence, because here's why. If I take 3, which is x, and put it in here, 2 times 3 would give me 6. If I take 2 and put it in here, I get 2. 6 plus 2 is 8. 3, 2 makes this true. That would be a solution. 2, 3 would not be a solution. And here's why 2, 3, let me erase this stuff out here. Here's why 2, 3 would not be a solution. Because if I put a 2 in for x, I'll use red. If I put a 2 in for x, I get 4. And if I put a 3 in for y, I get 3. 4 plus 3 is not giving me 8. 2, 3 is not a solution. I think that's a very easy thing to do. You're definitely going to be asked that in numbers 3 through 8 in the bookwork on page 219. You might want to pause the video and look and maybe try one or two of those. Make sure you're doing that right. We're just plugging the ordered pair into the open sentence and seeing if we get a true statement or a false statement. Moving on. Again, layer these. Let's start from scratch. Linear equations come in different forms. Now remember, linear means straight line. You see the word line. Linear straight line equations come in different forms. One form is standard form. If you go to page 216, middle of the page, you will see standard form. Standard form looks like this. A is a coefficient, it's some number in front of a variable. B is a coefficient, C is a constant. Here would be an example of an equation in standard form. Can you see how this looks like ax plus by equals c? In this case, a is 2, b is 3, c is 8. When I see an equation in standard form, I automatically know it's a linear equation. In other words, if I graph this, it has to give me a straight line. Okay? So maybe I should just write that in there. This graph must be a straight line. How do I know? Because this is in standard form, and standard form is always linear. It's always going to give me a straight line graph. There's another form of equation. It's actually not mentioned in this lesson, but I want to mention it. It's slope-intercept form. Slope-intercept form looks like this. Y equals, y is a constant right now, it would equal some coefficient times x plus a constant. So if I see this, you can see how this equation is in slope-intercept form. It's the same thing. This must give me a straight line graph. Linear equation, slope-intercept form is always linear. Okay, always going to be linear. So these two equation forms will always create a straight line graph. Now when you graph linear equations, which we will be doing today, this is my suggestion. I would start off solving these equations for y. If you keep them in standard form, sometimes you can think of ordered pairs in your head and get 3 or 4 ordered pairs and graph it. But if the standard form equation doesn't have convenient numbers to work with, you could spend a few minutes trying to find ordered pairs. So and it doesn't hurt us to solve for y. It's good algebra practice. I would solve the equation for y. That's the first thing. Make a table. Find at least 3 ordered pairs for your table. Graph the 3 pairs, and then take your ruler. You're going to draw a line through these points because the 3 points we came up with, there's more than just those 3. Those were just the 3 we did. Make sure you put arrows on each end. There's one other reason why I would recommend solving for y, and maybe I'll put that up here in blue. If you solve the equation for y, you can use your calculator to create your points. Your calculator can help you if you put the equation. If you solve for y, remember, look here, you see how this equation is solved for y? Y is by itself. If you solve for y, the equation's in slope-intercept form. Your calculator works with slope-intercept form. You see standard form, I'll put a little X next to that. Your calculator will not work in standard form. It does work in slope-intercept form. I think it'd be easiest just to do a couple examples, okay? So let's go to the bookwork, and let's take out a sheet of graph paper, and I'm going to go and let's work on number 12. Number 12. Okay, so the problem is asking us to graph y minus 2x equals 5. So my first instruction was solve for y. So I'm going to add 2x to each side. And when I do that, do you notice I have this equation in slope-intercept form? Now I'm going to make a table. I at least want to get 3 points. Now, this is a pretty easy problem. We can do this in our head, and I'll do it in my head, but I want to show you how I can also get this quickly on my calculator. So if you're not great at mental math and you want to use your calculator to help you out, I'm going to show you how to do that in a minute. But let's just put a few points in here first in our head, then we'll do it on the calculator. I'm going to put in 0, 2, and 4. If I input 0, 2 times 0 is 0, and if I add 5, I get 5. And if I input 2, 2 times 2 is 4, and 4 plus 5 is 9. And if I input 4, 2 times 4 is 8, plus 5 is 13. So there's 3 points. Now, let's say that I just wasn't great at math and I want to get this table on my calculator. I have a hard time with mental math. Okay, watch this. Here's my equation, y equals 2x plus 5. Go to your calculator. You might want to take your calculator and practice this right now. So take your calculator out. You got to pause the video, do it. You see where it says y equals? This button will allow you to type equations in slope-intercept form into your calculator. You see how this equation starts with y equals? This button allows you to do that. Now I had y equals 2x plus 5, so type in 2x. By the way, this key here, it is the variable key, x plus 5. Now next, I want to make a table of points. You see the graph key right above it, it says table in blue, probably, or maybe yellow, depending on your version of the calculator. If I hit second graph, it's going to make a table, so I'm going to do that, second graph. Now remember earlier, I did this in my head just a minute ago, I have the point 0, 5, 2, 9, and 4, 13. Look at what my calculator has. Look at my calculator. Can you see 0, 5, and 2, 9, and 4, 13? In fact, the calculator gave me a whole bunch of points. I can use any of them I want. Okay, so that's how you can use your calculator. Now see, if you don't put the equation in slope-intercept form, if you keep it in standard form, your calculator isn't going to help you. Okay, let's plot these points. Here's 0, 5. Here's 2, 9. And here's 4, 13. It's kind of going off my page a little bit. Now I want to take my ruler out. I want to draw a line through these points. So I'm going to get my line maker here. You would get your ruler. I'm going to draw a line through these points. Let me do that as best I can. Okay. This line is showing all the ordered pairs that would be on this line. So for example, you notice the point 1, 7 is on the line? Here's why. Because look, if I put a 1 in here, doesn't y work out to 7? Any point on this line would be a solution to that equation. Okay? Let's do one more, and then I think I'm going to stop the video. Actually, I got to do more than one more. Look on page 217. There's a couple special situations, horizontal and vertical lines. Look at the top of the page. When you see a simple equation such as the following, y equals 3, and they ask you to graph that, here's what that means. I want a line where every y value is 3. So let's think about that. Y equals 3 right here. Y equals 3 like this. Y equals 3 here. Y equals 3 on every one of these points. Now the x values, you notice, are changing. Like this point would be 3, 3, and this point here would be 2, 3, and this point here would be 1, 3. But you notice how y is always 3. The line for y equals 3 would be the following. It would just be drawing a horizontal line across my paper 3 units up, because no matter where you go on this line, y is always a 3. Okay? What about to the right at the top of page 217? Okay? What if I had a line, I'll do a different color here. What if they gave me an equation, x equals -2, and they want me to graph that line? Okay, let's find where x equals -2. And I'm going to erase that. Let me write it up again so it's clean. X equals -2. Okay? X equals -2 is right here. X equals -2 here. X equals -2 here, x equals -2 down here. Now, what's changing? The y value changes. Let me write these ordered pairs. This would be -2, 2. And this point would be -2, 1. And this point would be -2, 0. And this point would be -2, -1. You notice how the y values are changing, but x is always a -2. The line for x equals -2 would just be a vertical line where x is always -2. That's two special circumstances that come up. Now, if you look at the homework, and you look right now on page 219, problems numbers 19 to 22, you will notice these type of equations that I had just talked about in the last 2 or 3 minutes of the video. We need to be able to graph those. Okay, one last thing here, and I'm going to pause the video. We need to be able to graph a function if we're given a specific domain. Now, domain and range, remember, take us back to early on in the year, chapter 1. Domain means the values that you can input into your function. Okay, so remember, domain, I'll use D for domain, that's the x values, that's what you input. The range, remember, was the outputs, it was the y values. So go to number 26. 26 is asking you to graph this function with the given domain and then identify the range. Here's the function. y equals 3x minus 2. And the first thing I'm thinking is, thank you, book. You already put this in slope-intercept form. If I want, I could use my calculator to help me make a table. I don't think I need to, but I could. Okay, if you want to use your calculator and type that equation and make a table, you could. Now, look at the domain in number 26. The domain in this problem is x greater than equals 0. Here's what that means. I can only input x values that are 0 or bigger. Like I can't input -5. This says I can't do that. So I at least want to plot 3 points. I'll do 0. I'm going to pick 0, 2, and 4. Those are 3 values that are 0 or greater. Okay, let me do those. If I plug in 0, 3 times 0 is 0, subtract 2, I get -2. If I plug in 2, 3 times 2 is 6, 6 minus 2 is 4. And if I plug in 4, 3 times 4 is 12, minus 2 is 10. Okay, let me plot those. 0, -2 is here, 2, 4 is here, and 4, 10 is here. Now, in my prior problem, I just took my ruler out and drew a line all the way across my page. If I do that now, it would be wrong. Here's why I don't want to draw a line all the way across the page. Do you remember right here what my domain said? I can only use x values that are 0 or greater. So in other words, when I graph this thing, think about it. X equals 0 is here. I'm kind of using my pen to kind of show you. Maybe I should use a little yellow here. X equals 0 is right here. That means that I can only graph the values to the right of this yellow line, because x equals 0 is at this yellow line. I can only graph values right of that. I can only graph values bigger or equal to 0. So I'm not going to draw a line all the way across my paper. I'm just going to go from this point here, and I'm going to draw a ray just to the right. This shows the values that are bigger than 0 for x. If I go down here, maybe I should just do it in red. If I do this, I'm doing it in red, it's wrong. If I have a picture like this, this is wrong here, because these are values for x that are less than 0, and I can't do that. Okay? And there's one last thing I have to do. They now want me to write the range. Okay? Let's look at the range. The range are the y values. Okay? You notice the lowest y value I have on this graph is -2. And my y values keep on growing. My y values, the low y value is -2, and from that point on, my y values can just keep on growing. So my range would be y values that are greater than or equal to -2. So in other words, this is what this is telling me. I can only input numbers that are 0 or bigger, but when my function calculates this out and creates outputs, my outputs will always be -2 or bigger. That's what's happening here. I think I'm going to stop the video here. That covers what I needed to cover.